Alright, you are welcome to this tutorial video, and if you've not subscribed, please do well to subscribe, and God bless you. So quickly, I got us some questions. These are real post-UTME questions, and I would like us to solve them. So I've already gone through the basics of indices, but I believe you already know the basics already. So let's go quickly into the number one question. We are asked to simplify this 81 raised to the power of 3 over 4 times 27 raised to the power of 1 over 3 all over 3 times 2 raised to the power of 3. So like I said before, but when we see questions like this, the first thing we attempt to do is to make the basis the same. When we are solving indices problems, our first attempt is to make the basis the same. We don't have the problem with the power, but we need to make the base the same. So if we have this 81, what can we do to this base? Well, from what we are seeing here, we can get 3 out of this base, and we can get 3 out of this base. So let's look at how we can make this 3 raised to the power of something. So we can have this 81. We can write 81 as 3 raised to the power of 4, because 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 3 times 3, 9. 9 times 3, 27. 27 times 3, that's 4 times 3 in 4 places. That gives us 81. So we can rewrite this as 3 raised to the power of 4. Then we still have our powers 3 over 4. Now we have multiplied by, we have 27. Remember, we can rewrite 27 as 3 raised to the power of 3, because 3 times 3, 9. 9 times 3 is 27. So we can rewrite this as 3 raised to the power of 3. And then we have our power 1 over 3. All over 3. This is already 3, and times 2 raised to the power of 3. So remember the laws of indices we studied. If you don't have idea of the laws of indices, please check my previous video. I talked about the laws of indices, and we did vivid explanation on that, so you would get that. Just check the previous video. So from those laws, I said that when we have something like this, we multiply the powers. We have one inside the bracket and outside the bracket. What we simply do is to multiply the powers. So by multiplying the powers, we have 3 raised to the power of 4 times 3 over 4. That's the powers, times 3 raised to the power of 3 times 1 over 3. So if I multiply 4 times 3 over 4, I can simply cancel this 4 up here and cancel this one. So I'll be left with all over 3 times 2 raised to the power of 3. So if I cancel this 4 and cancel this 4 down here, I'll be left with 3 raised to the power of 3 times, we also have power of 3 times 1 over 3. This 3 can cancel this 3. Or if I simply multiply 4 times 3, I'll get 25. Of course, denominator will multiply. Numerator multiplies the numerator. This denominator over 1. 1 times 4 is still 4. 12 divided by 4 is 3. So instead of that, I can just simply cancel this and cancel this, cancel this and cancel this. So I have 3. 3 cancels 3 raised to the power of 1. So there's no need to write it raised to the power of 1. All over 3 times 3 raised to the power 2 raised to the power of 3. 2 times 2, 4. 4 times 2, 8. So we have 8 here. So you can see I already have this on ground. It's very simple. I can simply cancel this and cancel this, or I can simply, let's get the power of 3. 3 raised to the power of 3. 3 times 3, 9. 9 times 3, 27. So I have 27 times 3. Since this is multiplication and multiplication, the numerator is multiplication, the denominator is multiplication, I can simply cancel this 3 and cancel this 3. So I have 27 all over 8. Now 27 divided by 8, I'll be having a mixed fraction, so I can simply leave my final answer like this. So next up, I have the number 2. The second question, I have here is the cube roots of 64 raised to the power of 64r raised to the power of minus 6, and then raised to the power of 1 over 2. Now looking at this question, what I have here, I can simply look at this 64 rather. 64, what can I do to get down to I can simply rewrite this as cube root of 8 raised to the power of 2. Then I have r raised to the power of minus 6, and then 1 over 2. Well, this can be done in multiple ways, but I'll just use this way. You can try other ways to do it also. You might still get the same answer. Now if I have this, remember we said that from the law of indices, when a power inside the bracket multiplies power outside the bracket. So if I multiply this, I can multiply this times this and this times this. So I'll be having cube roots of 8. Okay, there's no need for the bracket again. 8. If I multiply 2 times 1 over 2, I'll be having 2 over 2 r minus 6 over 2. So this is what I'll be having. Now 2 can cancel 2, so I'll be left with cube roots of 8 raised to, there's no more power, 2 divided by 2, 1. There's no need to write 1 there, so I have r raised to the power of minus 3. So I'm left with r raised to the power of minus 3. Now, since I have this left, I can rewrite this. Don't forget cube roots. Now I can rewrite this as cube roots of 2 raised to the power of 3, because 2 raised to the power of 3 is 2 times 2 times 2. 2 raised to the power of 3, r raised to the power of minus 3. Now also recall that we said that cube can be written as, sorry, let me rule a line here so that we can have more space. Now also recall that we said that roots can be written as, I can rewrite these cube roots as 2 raised to the power of 3 r raised to the power of minus 3 altogether raised to the power of 1 over 3. So I can write this as this. So if I write this as this, I can simply the same thing, multiply the power inside and the power outside of the bracket. So I have 2 raised to the power of 3 over 3. 3 times 1 over 3, 3 over 3. R times minus 3 times 1 over 3 over 3. So I'm left with 3 over 3, 1. R raised to the power of minus 1. So that's what I'm left with. So I can decide to leave my answer like this, or I can write it as 2r over 2 raised to the power 2 over r rather 2 over r, because these things recall from, we also said that raised to the power of r means 1 over r minus, because of this minus sign it becomes 1 over r. So I'm left with, let me write this, 2 over r. Third question, we have roots of 160 r raised to the power of 2 plus root of 71 r raised to the power of 4 plus root of 100 r raised to the power of 8. So quickly, to solve this, I'll start from this list root here. So I still have the bigger root of 160 r raised to the power of 2 plus root of 71 r raised to the power of 4, then plus roots of 100. Now I can write 100 as 10 raised to the power of 2, because 10 times 10, that means 10 in 2 places, 10 times 10, which is 100. So I can write it as this, if you would agree with me. So I have raised to the power of 8. Now we know that I can rewrite this Let me bring back my big root. 160 r squared plus root of 71 r4 plus, I can rewrite this as 10 square r raised to the power of 8 and then 1 over 2. Recall that I said in my previous video, we already sorted out this, that the roots can be rewritten as the power of 1 over 2. For example, square root. So that's how I wrote this as 1 over raised to the power of 1 over 2. Now, since I have this, I can simply multiply the powers. Remember, power inside the bracket and power outside the bracket. I'll multiply this 2 times 1 over 2. I'll multiply this 8 times 1 over 2. So I'll be having my bigger root 160 r squared plus 71 r raised to the power of 4 plus 2 times 1 over 2 is 2 over 2, which is 1. So I have 10 raised to the power of 1. There's no need to write the 1. 8 times 1 over 2 is 8 over 2, which is 4. So I can write this as 4, multiplying inside what is inside the bracket and what is outside of the bracket. So I have this. Now, since I have r raised to the power of 4 and r raised to the power of 4, I can simply add this. Since these coefficients are the same, I can add them. So I have my root of 160 r squared plus root of 71 plus 10 gives me 81. So I have 81 r raised to the power of 4. Now, since I have 81, I can write this as 160 r squared. Now, the square root of 81 is 9. So I have 9. And then I have r raised to the power of 4. So having this, I can write this as, in brackets, 1 over 2. So I have r raised to the power of 1 over 2. The square root of 81 is 9. So I'm already sorted that out. So I have square root of r raised to the power of 4 and this square root of r raised to the power of 4, which can be written as 1 over 2. So I have this as 160 r raised to the power of 2 plus r plus 9. 4 times 1 over 2 is 4 over 2, which is 2. So I have r raised to the power of 2. Now you see, we are gradually dismantling the roots. We started from this right hand side and we moved to this part, and now we are left with just one root left. So we can add this together. Since the coefficients are the same, we have r raised to the power 2 here, r raised to the power 2 here. So we can add this together to have 169 r squared. So having 169 r squared, I can take the square root of 169 r squared. So the square root of 169 is 13. And then the square root of r squared, square root, the roots, which I also have 1 raised to the power of 1 over 2. So root of r squared is r, because the power will cancel the roots. So I have r left, which gives me my final answer. I hope you get this very clearly. It's very simple. These questions comes out in JAMB, UTME or WAEC objective questions. Very easy to solve. So it shouldn't be a problem to you. I hope you enjoyed this tutorial video. Please do well to like and subscribe. Subscribe to my YouTube channel to get more videos from me. Thank you. God bless you.